We're still in section 2.2, solving complex equations, and we're going to work on example 4. We're going to fill in this verb table. My husband was just in here talking to me, and I invited him to stay and listen to me demonstrate how to input the verb table information. He said no, that he had verbed enough, and so he left the room. Okay, so we're going to fill in this table here. And when I have to be honest with you that when I first did these problems, these electronics problems, and I saw these tables, it took me the longest time to figure out what on earth they wanted. So I'm going to give you the benefit of what I learned so you don't have such a hard time like I did. Okay, the thing that I want you to pay attention to is that this V row has to do with voltage, all of it. This is the total voltage of a circuit. This is the voltage at the resistor 1 location. This is the voltage at the resistor 2 location. I is current. This is going to be total current. This is going to be current at resistor 1. This is going to be current at resistor 2. This is the resistor information, total, resistor 1 and 2, and power, total at resistor 1 and 2. So we're going to fill in some information just by looking at the diagram. This is a parallel circuit, and the reason it's called a parallel circuit is because when the voltage is passing through the circuit and it goes to the resistors, it goes to both of these resistors at the same time. And you might say, well, how can that be? Clearly resistor 1 gets the voltage first and then resistor 2. Well, that's true, but it's going so fast that they essentially are both getting it at the same time. So the first thing I'm going to do is set this aside is I'm going to fill in the information. This guy over here, he represents the total voltage. So that 16 is going right here. Total voltage. My resistor 1, here's my resistor row, and there's resistor at 1 is 8.4, and my resistor 2 is 6.7. Okay, now the information that I'm going to use to fill in this table is this stuff right here, and that all pertains to a parallel circuit. And I'm also going to be using this formula up here, the Ohm's law formula and the Watt's power formula, or the Watt's power formula. Okay, so let's take a look at these guys and examine them. And one of the things that I noticed right away is that in a circuit like this, the voltage at the first resistor is the same as the voltage at the same resistor at the second resistor, which is the same as the total voltage, and that's because it is a parallel circuit. Well, I know the total, which means I know these next two guys right here. Okay. All right. Now let's take a look at resistance. It says that my total resistance, which I don't know, is equal to these two guys multiplied together divided by these two guys added together. So I'm going to calculate that. So I have R sub t is equal to this guy times this guy. So it's 8.4 times 6.7. And 8.4 plus 6.7. So I am going to put that in my calculator. So I have 8.4 times 6.7. So my numerator is 56.28 divided by, now the parentheses are critical here, 8.4 plus 6.7. Close the parentheses. Ta-da! So I get 3.7271. Now, how do I know where to cut this thing off? Well, let's take a look at the information that's given in the problem. And it only takes it out one place, so it would be safe to say that we should just round ours off to one place as well. So this is going to be 3.7. 3.7. All right, so I'm ready to find my current and I'm ready to find the power. And I don't have anything there. But what I do know is that voltage is equal to my resistance times R. Voltage is equal to resistance times R. And if I know that, and I'm looking for I, I'm going to go ahead and just divide both sides by R. And I end up with I is equal to V over R. I equals V over R. And that's the formula that I'm going to use to get him, him, and him. So it's 16 divided by 3.7. 4.3 Move that over just a little bit. 16 divided by 8.4 is 1.9. And 16 divided by 6.7. I'm going to round him to 2.4. 2.4. Now let's go over here and look just 1 second. This thing over here says that if I know these two guys, 1 and 2, if I add them together, I get the total. Well, if I know these two, and I do know these two guys, I just did all three of them. 1.9, we're just going to check it out. 1.9 plus 2.4 equals 4.3. Perfect, they match. They may be like 1 decimal point off, but we're working out pretty good. They match. Now let's do the same kind of thing for the power. Power is equal to voltage times current. So for my power, voltage times current, 16 times 4.3, 68.8. Voltage equals, or power equals voltage times current, 16 times 1.9, 30.4. And one more time, 16 times 2.4, 16 times 2.4, 38.4. So there you have it. We just filled in the VERP table. Not so bad when you know what you're doing. Okay, one more to go.